Alright, this is a IXL Grade 8, and this is section J10, percent of change. In this one, what we're looking at is the percentage from one number to another. So in this case, we have two examples. We'll do a few more. We're at 4 to 1. So what percent of change? And what we're really doing is comparing the difference between these two, in this case, the difference to the original number. In this case, so our original number is 4, so we have 4 on the bottom, and the difference means we subtract 4 minus 1. So this is 3/4. So it's 3/4, hopefully you know, is 75%, or 0.75 is a decimal, and we look at these are out too much. So is it a 75% decrease or increase? Well, we went from 4 down to 1, so that is a decrease. So again, you're taking the original minus the new number and dividing it by the original. So you're setting up a ratio and then just reducing and converting it to a percentage, either increase or decrease. So this one we have 100 to 32. So that's 100 minus 32. In this case, the original is 100. So this one as a percentage should be pretty straightforward. It'll be 68 over 100. So in this case, 68%, and it's already told us it's a decrease because we went down from 100 to 32. All right, a couple more examples. All right, so we have bigger numbers, but ultimately, the bigger the number, it doesn't matter. We're still setting up a ratio. So 8,000 to 10,000, we already know that's an increase because it got bigger, so we can eliminate these two decreases. So that's a good test-taking skill for multiple choice. So now we say, okay, well, 10,000 minus 8,000 over the original number, which is what we started at, 8,000. So 10 minus 8 is 2, so this is 2,000 over 8,000. Now we can do some reducing here, and we get 2 over 8, which reduces to 1 over 4. Now hopefully you saw that before we did the reducing. But 1/4 as a percentage is 25%, so we find 25, and sure enough, it's right there. So it's no longer that one. All right, so for this one, we're going from 75 to 87. That's an increase. So we find the difference, and we divide that by the original. So 75 on the bottom, and 87 minus 75 is 12. So if we do a little reducing, I see that, well, 3 goes in evenly, so that's 3 times 4, and 3 times 25. Well, 4/25, if I want that in hundredths, I have to multiply both by 4. And that's going to be 16, and so now it's in our handy-dandy percent ratio, so I know this is 16%. So again, sometimes you might know directly what the percentage is, or they may give it to you in a form that you can easily convert to percents. All right, so now we've gone from 40 down to 22, so this is a decrease. So we can get rid of these two increase ones, and we can't really even guess because they're pretty close. So let's figure it out. 40 minus 22 over the original, which is 40. So this is 18 over 40. So now if we do some reducing, let's do it in black here. So this I see is 9 times 2. This is 20 times 2. 2 is reduced. So now I'm set up that I can get this into a percent ratio. So 20 times 5 is 100. So 9 times 5, and that's 45. So this is a 45% decrease. All right. In the last two examples, 18 to 27, that's an increase they've told us. So 27 minus 18 over the original of 18. It's 9 over 18, and hopefully you can see that that's 1/2, and therefore 1/2 as a percent is 50%. So again, you're finding the difference and dividing it by your original starting number. And that's the percent of change. How much did that original number change? That's why it's always in relation to the original number. This one looks awfully hard because it's got decimals, but we don't really even have to worry about the decimals. If we say 51 minus 24 all over 24, we'll get the exact same answer as if these all had decimals. But this way we don't have to deal with the decimals. So we have 51 minus 24 is 27. So this, I see 3 goes evenly to both. This is 9 over 8. So this is 1 and 1/8, which is 1.125. And to convert this to a percent, that becomes 112.5%, because the decimal, when we convert to percents, moves over 2 places. So this one is more than 2.4 above, so that's why it's more than 100%. If it were exactly 2.4 above, meaning 4.8, then it would be a 100% increase, but this one's just a little bit more. So again, find the difference between your two numbers, divide that difference by the original number, and that's your percent of change.